the next topic we need to review is the set theory. Set theory is something that we will also use from time to time in all our consideration later in the class. Okay, but so let's start from basics. Set is a collection of elements. So we can say that set can be collection of numbers, collection of apples. But of course in the set we can have bananas, screws, everything. Right? So this set is simply a collection of elements. Okay, now before we will do some things with those sets, let's introduce some terminology that will be very useful to us later. Okay, so we start with universal set. Usually denoted by Greek letter omega, and this is a set of all considered elements. Now, sometimes instead of universal set, I might just say universe, but it will mean exactly the same thing. The next thing we should introduce is empty set. We denote it like this, and this is a set with no elements. So, as the name suggests. Okay, now, if we see something like that, we read it as X is an element of A, where A denotes set. Look, generally we prefer to denote sets by capital letters, or the element we denote with lowercase letters. Okay, and of course, by the same token, we can say that this means X is not an element of A. Okay, now, if we see something like that, A equals to B, we call those equal sets. So those are the sets with exactly the same elements. Okay, so we are getting a lot. What else should we include here? Okay, B. When we see something like that, we say that B is a subset of A. What does this mean? It means that B is contained within set A, which means that B is like a portion, so a smaller set of elements, all contained with A. Or the sets are the same; they are equal sets. Of course, this is when we introduce also this symbol, which means that B is a proper subset subset of A, and at the same time B is not equal to A. Okay, now look, a lot of things associated with sets we can present using Venn diagrams. Venn diagrams is probably something that you've seen in high school as well on many occasions. Okay, so for example, usually we start drawing Venn diagram like that. So this is some rectangle. Now, all the elements within are our universe, right? This is like our universal set. Now, we can, within this, we can draw some subset A. And we will see basically what portion of the universe it involves. We can also show show elements. Like we could say that here we will have x1, x2, which are elements of set A. But we clearly see that y1 element that is over here is not an element of A. So in this case we could write that x1 is an element of A, but y1 is not an element of A, which we clearly see from this graph. Okay, and look, we will be using Venn diagrams to demonstrate how different operations on sets work. Okay, so let's move now to sets operation. So operations on sets. Okay, and we're going to start with union. Now, look, union of A, we write it as A union union B. Okay, so A, let's do it differently. A union B is a collection of all x's such that x is an element of A or x is an element of B. So, how can we show this situation on Venn diagram? Look, we can have different situations over here. Now, first, we can have disjointed sets. Disjointed means they do not have the common part. Like, if union of these two sets are all the elements that belong to the set A and all the elements that belong in a set B. Now, of course, we have a situation that those two sets have a common part, but still union takes all the elements that are either in one set or in other set, right? So we collect them all. Now let's get to now we can get to operation number 2. In a second, once we've established the main operations, I will show you the examples on how it works, but let's just wait a second. Okay, so next is intersection. intersection, and we write it as A intersection B, and those are such x's that x is an element of A and x is an element of B. Look, what is the difference between those two? We see that here we've got or, here we've got and. And means that those two requirements need to be fulfilled at the same time. So look, now I want to have, if we have two sets, A and B, I want to have only the part that is common to both of these sets. You see, only this part over here is common to both sets because x needs to be an element of A and needs to be an element of B. But what if we had a situation when A and B are disjointed? Well, in this particular case, we need to say that A intersection B is simply an empty set. Okay, then next thing we're going to have is complement. Of A. So we will denote it as A prime. So this means the complement of A. And those are all the elements x such as x is an element of the universe and x is not an element of A. Now, how do we see that? Look, basically this is our universe. Here is set A, then everything, okay, we can just read it from here. Those need to be the elements that are in universal set, but are not elements of A. So basically, complements of A is everything that you can see over here. So all the space over here represents the complement of A. Of course, if A is equal to the universe, then we will have that complement of A would be an empty set, right? Okay, and the last operation we're going to cover is a difference. Difference, so we write it as A difference B, is a collection of all x's such that x is a member, so is an element of A, and x is not an element of B. Okay, so how can we show this on the graph? Well, if here is my set A and here is my set B, I just want to have those x's that are members of A but are not members of B, right? Look, here you see that we've got this common part, right? So this is the common part that we need to take out of A, and the thing that interests us is what we will have over here. This is our difference. Again, if A and B are disjointed, A, you've got B, then A difference B say that what we need to do when we take the difference of two sets, we need to take out of the first set the common part. Okay, and actually, as I was mentioning to you before, we are going to deal with only basic operations. So for now, this is enough. If we'll need anything else from the set theory, we will introduce it later in the course. Okay, so let's do an example. Look, let's just say that universe is made out of letters. It's A, B, C, D, E, F. Not actually, that's enough. And now, let's just say that set A is A, B, C, D. While set B is C, D, E, F. Okay, now let's perform all the basic operations. So, let's start with A union B. So, those are all the elements that are in A or in B. So, A, B, C, D. C repeats itself, and we get new elements E, F. So basically, in this case, we would have that this is A, B, C, D, E, F, or our universal set in this case. Okay, now, what is A intersection B? Now, we want elements that are in set A and in set B. So we need to find a common part. We see that CD is the common part of the two sets. Okay, now complement of A is everything that is in the universe, but it's not in A. In our case, universe is A, B, C, D, E, F. A is A, B, C, D. So this must be E, F. And look, by the same token, complement of B must be, of course, A and B. Then we can find the difference between set A and set B. So those are all the elements that are elements of A, but are not elements of B. So look, we just need to subtract the common part, which we know is C. So this will be A, B. Then, from set B, if we want to make a difference between B and A, we would find out, of course, that this is E and F. Okay, I know that this example is pretty trivial, but I think it shows how to perform every operation on sets that we've considered here this far. Okay, maybe let's just do one more example. In the exercises I have provided for you, you will find more examples on the applications of sets. Okay, but so let's start with something. Let's do one more example. Okay, so our universe are real numbers. So all the real numbers. Then our A are positive real numbers. B are all the x's such that x belongs between -2 and 2, and C are negative real numbers. Okay, and just let's try to balance. Okay, now what if we have A union B? I'm sorry, union C. Let's start with this. Look, here I take all real positive numbers, real negative numbers, I'm going to add them up. And I'm going to come up with universe almost, right? Because here we have negative, positive numbers. What are we missing? 0. We can simply write it as that this is universe, so real numbers, excluding 0, right? Because we are excluding 0 using the difference. Okay, what else? Oh, okay, what? A union B, in this case, would be a set of, we can write that those are the numbers from -2, right, to positive infinity. And, okay, so now if I will have A union B union C, what will I have? Positive real numbers, negative real numbers, and here between -2 and 2, we've got 0. So I can write real numbers, or I can write the universe. Okay, now what is the common part of A and C? So what is their intersection? Nothing, right? Positive and negative numbers. So this would be an empty set. How about B, common part C? In this case, we see that those numbers start with -2 and go to 2. Those numbers start with negative infinity and end up just before 0. So here we could write that the common part is the part from -2 to 0, excluding both. Okay, and what is the difference? Okay, so what is the complement, maybe first, of A? Well, if A is positive numbers, positive real numbers, then the complement must be negative real numbers, but with 0, right? And now, what is the complement of B? Well, complement of B will be all the numbers from negative infinity to -2, but including -2, as well as the numbers from 2 till infinity. Okay, we've made those. Now we need to have maybe maybe what is the common part? Oh, so intersection of A, B, and C. Look, here we've got negative real numbers as C, positive real numbers as A, and this. So what would be the common part of all three of them? Well, let's think about it. If A and C do not have a common part, then including B would change anything? No, this would still be an empty set, because here we are required for all the three sets, to get a common part. Okay, now what we need is a difference. A, difference B. So if I'm going to take real numbers and a positive and exclude from the negative real numbers, what I'm going to get? A. Oh my god, I wanted to say C. Now, in case of C, I will have C. Okay, and finally something, maybe what is the difference between A and B? Well, we need to cut out some part of the real numbers, positive real numbers that is here, right? So those will be numbers from open 0 to 2. So this 2 to infinity. And look, I hope you can practice more combinations. You can make the operations here more complicated, but basically the logic behind all the set operation was explained, and I think you should not have any troubles implementing it further. Okay, so thank you for your attention. In the next video, we're gonna start matrix